Hi guys, in this video we're going to talk about physical and chemical change. I'll firstly define what I mean by change, and then we'll talk about physical change, then chemical change, and I'll throw nuclear change in there at the end just to be sneaky. So when we talk about change in science, we're talking about one substance turning into another substance. And as I said, there are three different types of change: physical change, chemical change, and nuclear change. When we talk about physical change, no new substances are being formed. It may change its physical properties or what it looks like, but the substances that are there are actually staying the same. So for example, a change of state, so when we go through solid, liquid, and gas, or in the opposite direction, is a good example of a form of physical change. And this is a reversible reaction. You can go from ice to steam and from steam back to ice just by changing the amount of energy that you have in that water. So as ice turns into water, which turns into steam, although these things look different and have different physical properties, they're the same thing. They're still H2O or water. They're just in different states. Another example of this is when we change the appearance of something using physical methods. So that might be cutting something up or grinding or putting something through a wood chipper like wood. And so the same substance, again, the substance isn't being changed. We have the same substance at the start and the big end. So if we take a wooden log and we cut it up with a wood chipper into small bits, we end up with wood chip. Now it looks different, but in essence, it's the same thing. We're going from wood in log form to wood in chip form. It's just smaller pieces of the same thing. So this is also a physical change. Chemical change, on the other hand, occurs when we actually change the substances that are there. The way that we do this and produce new substances is through rearranging the atoms and breaking the bonds and reforming bonds between those atoms to create whole new molecules. So an example of this is combustion. So when we burn those, take those wood chips, all the wooden logs, and we burn them, we're actually changing the form that they're in. So the wood mixed with the oxygen in the air through the process of combustion is going to produce charcoal that's left over, which is a form of carbon, and smoke, which is also a form of carbon, and gases such as carbon dioxide and water vapor. So these are different things, and you can see that those atoms have been rearranged and split up into different things. So they're forming completely new substances with new properties that weren't there before. Now, there are a few different ways for us to tell that a chemical change has occurred. Now, the first one is a permanent change in color. We said before that physical change is a reversible process, like a change of state. In a chemical change, it's hard to, unless you can use chemical means, but it's much harder to change the substances back to where they were before. So you end up with a permanent change in color. You might also see a gas being produced. So for example, if you mix a couple of things together and they start bubbling, that's telling you that a chemical change is occurring because a gas is being produced. If you were to mix two liquids together and a precipitate or a solid were to form, or the solution was to go milky, that would tell us that there is a chemical change as well, because that solid is being produced where it wasn't there before. And the last way that we can tell whether it's chemical change that has occurred is that energy is being either absorbed or produced. So this could be in the form of heat energy, so it could absorb heat energy, so therefore be cold, or it could produce heat energy and whatever you've just mixed together will become hot, or it may produce light energy in the form of light. So going back to our example of combustion, we know that, well, we can't see the gases that are being formed, but there are gases being formed, but there are colorless, odorless gases, so we don't see them. But what we do see is a change in color. We go from the brown color of wood to the black or white color of that charcoal, that carbon. We also see energy being produced, energy both in the form of heat, because fires will warm you up, so that's heat being produced, and in the form of light, because that flame will actually light up an area around it, so that's light energy being produced as well. Now, I'll just briefly talk about nuclear change. So nuclear change, instead of rearranging the atoms, it actually changes the atoms internally, and not just new substances or new compounds are produced, but instead new atoms are produced. So it changes on a subatomic level within those atoms, the amount of protons, neutrons, and electrons, and that then changes the element that we've got. In this video, we've talked about change being the way that things change form or new things are produced in science. Physical change being a generally reversible process, including change of state, where no new substances are formed. They just change the way that they appear. Chemical change, where new substances are formed through the rearrangement of atoms. And nuclear change, where new atoms are created through the rearrangement of subatomic particles such as protons, neutrons, and electrons. Thanks for watching, guys. Peace out.